Welcome to another edition of Math with Gilbert. So anyways, today for my pre-APers, we are going to be doing scientific notation and standard form. Now, you might be asking, what is scientific notation and standard form? Well, scientific notation is a way to write very large numbers and very, very small numbers. These are numbers usually with lots and lots of zeros. We're talking millions, billions, trillions, and quintillions. And then also very small numbers. So these are numbers that are much, much, much smaller than zero or smaller than the number one. They can be negative or positive. And let's move on. So this is an example of a number written in scientific notation, 7.83 times 10 to the fifth. And there's different parts to these numbers. There's the coefficient, that is the number in front. You have your base, which is a times 10. So every single number in scientific notation is always going to be times. And this is your exponent. This number is going to represent how many times you move your decimal. So once again, coefficient, your base times 10, this times 10 will never change. Anytime you ever write a number in scientific notation, it will always, 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 always have the times 10, and it will always have an exponent, but that number will change. Okay. Positive exponents are large numbers, and negative exponents are going to be your very small numbers. Moving on. So now I want to show you guys how to convert a number from standard form, which is how we typically write numbers, into scientific notation. All right, so we have 35, 100,000, million, billion, 35 billion. And we're going to add a decimal after the very first digit greater than zero. So we read numbers like we read words. We always go left to right, left to right. So our very first digit that's greater than zero is going to be, the very first number is going to be this 3. So we're going to add a decimal behind the 3. Then we're going to rewrite the coefficient without any extra zeros behind it. So then now it's going to be the extra zeros. We have 3.5, then we've got all these zeros. So we're just going to write 3.5. And then we're going to add our times 10, always. And now for the exponent, how many times do we move that decimal? Because in 35 billion, the decimal's back here. And so we're going to count how many times do we move that decimal to get it where it goes now between the 3 and the 5. Count the number of digits from the decimal to the end. And we come up with 10. It moved 10 times. So 35 billion in scientific notation is 3.5 times 10 to the 10th power. All right, so let's do a few of these. Oh, where'd that go? Here we go. All right, let's do a few. Let me change the color to white. Okay, so we have 45 million. So first thing we want to do is we want to put the decimal behind the very first number that's greater than 0. So just like we read words, we're going to go left to right, and the very first number is the 4. So I'm going to put the decimal behind that. So I'm going to rewrite that as my coefficient. 4.5. And I'm always going to have my times 10. And what's going to go here? What's my exponent going to be? Well, how many times did I move the decimal? 1, 2, 3, 4, 5, 6, 7 times. So my answer is going to be 4.5 times 10 to the 7th power. I'm going to do the next one, or if you want to go ahead and pause the video and try this one on your own, you can do that. The first thing I'm going to do is put a decimal behind the very first number that's greater than 0, which if I read from left to right is going to be this 1. I'm going to write my coefficient. Remember, I write everything except the zeros. So now this time I'm going to write 1.19 times 10, always the times 10. And how many times this decimal will get moved? 1, 2, 3, 4, 5, 6, 7, 8. 8 times. My answer is 1.19 times 10 to the 8th power. Okay, I'm going to show you guys one that I want to look at. Let's look at the number, just to show you something a little different. Let's look at the number 103,000. 103,000. So if you notice, now I've got a 0 in between these two numbers, but nothing really changes. I'm still going to add a decimal behind my very first number greater than 0, which is this 1. But now I'm going to write 1.03. Anytime there's a number that's not 0, I am going to want to fit that in my coefficient. So 1.03, always put the times 10, and my power is going to be 1, 2, 3, 4, 5. 1.03 times 10 to the 5th power. The third example on this page was 6,000. So we're going to put our decimal behind the first number greater than 0, which is the 6. So now I'm left with 6. I don't need to write anything after that decimal because they're all zeros. So this one's going to be 6 times 10 to the 3rd power. 6 times 10 to the 3rd power. Moving on. All right. So now what happens when they're very small numbers? The rules are very similar. The only thing that really changes is the exponent. And we'll show you that in a second. So first, we're going to add a decimal right after the very first digit greater than 0. So like I said before, we read numbers left to right, like we read words. And the first number we come across that's greater than 0 is this 4. So we're going to place the decimal right behind the 4. And now this 4.57, that is my coefficient. Here's the front of it. So 4.57, and then scientific notation, what comes next? Always the times 10. And now my exponent. So my decimal was here, but I moved it between the 4 and the 5. So how many times did it move? 2, 3, 4, 5, 6, 7 times. And because this number was originally smaller than the number 1, because it was a very small number, my exponent is negative. So anytime you have a very small number, your exponent is negative. Anytime you have a very big number, your exponent is positive. All right. So here's my decimal, and I need to move it behind the very first number greater than 0. So it's going to move between the 7 and the 5, and that is my new coefficient, 7.5. Always write your times 10. And because this number is small, I already know my exponent is going to be negative. But what is this number going to be? Well, how many times did I move the decimal? 1, 2, 3, 4, 5. My answer is 7.5. Or 7.5 times 10 to the negative 5th. Number 2, what is my very first number that's greater than 0? It's this 5. So I need to put my decimal between the two 5s, and I end up with 5.578. Always put the times 10. It's a very small number again, so I know my exponent's going to be negative. And how many times do I move it? 1, 2, 3. 5.578 times 10 to the negative 3rd power. Let's see, we got one more to do, but I need to look at the example. 0.1, 2, 3, 4, 5, 6, 7, 8. Okay, the last one we have is 0.1, 2, 3, 4, 5, 6, 7, 8. 0.000000009. So Once again, move the decimal behind the very first digit greater than 0. That's a 9 right here. So the decimal has to go here at the end of it, 9. I need to write my coefficient. 9 point, is there anything after it? No, so it's just 9. Always write your times 10. This is a very small number, so I know my exponent's negative. And I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. 9 times 10 to the negative 9th power. That is incorrect. That should be a 9. Okay, so now practice on your own. So I'm going to give you a problem. Pause the video. See how you do. All right, now we're going to convert from scientific notation into standard form. So here's an example. So 3.77 times 10 to the 6th power. And now we're going to rewrite only the coefficient. So 3.77. And now we're going to move the decimal this many times to the right. Because that is a 6 of the exponent, we know we have to move our decimal 6 times. What you can also tell is that because this 6 is positive, that this number has to be a very big number. If it were negative, it would be very small. So after we move it 6 times, 1, 2, 3, 4, 5, and 6, we end up with the number 3,770,000. If this number were negative, we would have moved the decimal to the left. But because it was positive, we moved it to the right. So now we have a negative exponent example. So we're going to start with writing only our coefficient, 2.4. And now we know that this number has to be very small because the coefficient is negative. I'm sorry, not the coefficient, the exponent is negative. So we know we're going to move our decimal to the left. And it is a 5, so we're going to move it to the left 5 times. And after you move it to the left 5 times, you end up with this number, very, very small number. So we're going to do a few. If you want to do these on your own first, you can. So 4.7 times 10 to the 5th. We're going from standard notation, or from scientific notation to standard form. So rewrite the coefficient, 4.7. Now this exponent is positive. So because it's positive, I know I got to have a big number. So move my decimal to the right 5 times. 1, 2, 3, 4, 5. And I end up with 4, 7, 0, 0, 0, 0, 470,000. This example also has a positive exponent. So rewrite my coefficient, 8, 2, 0, 2. And my decimal needs to move 3 times to the right because it's a positive exponent. 1, 2, 3. And I end up with 8,202. Let's see. And the last one says 6 times 10 to the 9th. So here's the third example. 6 times 10 to the 9th. So rewrite my coefficient, which is a 6. I need to move my decimal 9 times to the right because it's a positive number. So where's the decimal in 6? I can't see it. Well, just like any other number, you know that is always at the beginning of the number. So originally the decimal's here. I need to move it 9 times to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I end up with 6, 0, 0, 0, 0, 0, 0, 0, 0, 0. 100,000, million, billion, 6 billion. A lot of zeros. Again, that should be a 6, not a 9. All right, now we're going to go the other direction. 3.3 times 10 to the negative fourth. Now our exponent is negative, so we're going to be moving the decimal the opposite direction, to the left. So rewrite the coefficient, and I need to move my decimal 4 times, and because it's negative, it's going to be a small number, so it goes to the left. 1, 2, 3, 4. There's my decimal, so my new number is 0.00033. Number 2. You can pause it if you want to try this one on your own. Rewrite the coefficient. 1.23 and negative. So my decimal is going to be going to the left 6 times. 1, 2, 3, 4, 5, 6. So my new number is 0.000000123. Very small number because the exponent is negative. And we have one more. 7 times 10 to the negative 8. 7 times 10 to the negative 8. Rewrite the coefficient, which is just 7. And my decimal, well, where is it? Once again, it's hidden. You can't see it. So you know it should be at the front of the 7. And it's going to the left 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So I'm left with 1, 2, 3, 4, 5, 6, 7. A very small number. Move my decimal 8 times. And that is all for scientific notation. If you have any questions, you guys can email me or make sure you come to the Zoom tutorials. Have a good day.